In this lesson, you will graph and analyze dilations of radical functions and graph and analyze reflections and translations of radical functions. So first of all, what is a square root function? It is a function that contains a square root of a variable. So you'll notice the variable is underneath the square root. It's in the radicand. A radical function is a function that contains radicals with variables in the radicand. So this is kind of the same thing, a square root function and radical function. You can call it either one. And remember that the radicand is the expression that is under the radical sign. So in this type of function, you are going to see a radical, and you're going to see either a radical x or a radical something done to the x. So let's just graph radical x and see what happens. And let's start by using a table. Now, if you would like to use Desmos to do graphing, you absolutely can. I'll show you how to do that in just a moment. But if you would like to graph just using a table of values, you can do that as well. So let's see what's going on. One thing we know about radical functions is you cannot do a radical of a negative. You can't do the square root of -1. That creates what's called an imaginary number. So you have to start at 0. So we start at 0, we'll try 1, 2, and 3. And if you want to look at some fractions, you can as well. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is about 1.4-ish. You can check that on your calculator. Square root of 3 is about 1.7-ish. Square root of 4 is 2. And so what you'll notice about this graph, it starts at origin. It's going to hit 1, 1. And then at 2, it's going to be a little bit more than 1, a little bit closer to 2, at 3, and then at 4, it's exactly 2. And it's going to create a curve. Just like we see with an exponential function, this is a radical function, which is the inverse of it. So it's going to create a curve that's going to go this direction. So to see what that looks like on Desmos, I'll just pull that up here. This is what it looks like on Desmos. So here's that origin, here's the point 4, 2, and you have this curve that is created by that radical function. So when you type it in, if you'll notice here, I just did the square root of x. Your square root key is right down here on Desmos, and then your x key is right here, and then you can do any other numbers that you want to do. Okay, so let's talk about the domain and the range here. If you'll notice the domain of this function, I can literally try any value of x as long as it's greater than or equal to 0. I could try 1/2, I could try 1.5, whatever you'd like. For the range, if you'll look, I'm not going to have any values that are below 0. So these are also going to be, oops, it's a y, sorry about that. So it's going to be y such that y is greater than or equal to 0 as well. So this is called the parent function because that's the radical of x. Depending on what's multiplied in front of it, what's inside of it, it'll make it move in different directions. So let's see what 2 radical x looks like. So I'll just pull up Desmos real quick here. And so I'm going to type in, and it's going to be a different color, 2 radical x. And if you'll notice then that curve is wider. So if I multiply that radical x function by something else, it's going to make it grow. And let's talk about the domain and range. The domain is still going to be greater than 0, and the range is also going to be values greater than 0. And you'll notice your curve is just a little bit wider. So you try the example in your notes. Now, in your notes I have typed this function, and where you start is with the graph of y equals radical x. Then you're going to always, if there's addition or subtraction, that's how much it's going to move up or down. If there is any addition or subtraction inside the radical, that's how much you're going to move left or right. So adding or subtracting outside is up and down, inside is left and right. And then when you graph and it's just an x with a multiplication, you can see what happens to the graph. So let's try -3 radical x. Let's see what happens with that graph. So I'm going to go back to Desmos. I'm going to change this 2 radical x to -3. I'm going to move this down so that you can see this curve. The negative in front makes it reflect. So this is a reflection of the curve. That's why it is going below. And the 3 multiplied makes it wider, dilated. So this is going to be a wider curve than your parent function. So you graph the example in your notes of a dilation. Now this, you'll notice, is an addition of outside. So based on the rules that you have in your notes, we know how it should move. This is an example of a subtraction that's inside. And so on your notes, you should know how it should move. So let's check those both on Desmos. And then we'll talk about the domain and the range of those as well. So let's try the first example where you are if you noticed, you have to scroll outside of this radical, otherwise it'll type it inside the radical. So this is my graph of radical x plus 1. Since it's outside, it's going to move it up 1. And so this curve is moved up 1. Now, the domain is the same. It's still going to be all values greater than 0. But if you'll notice, the range this time are going to be all values that are greater than or equal to 1. It's never going to go below 1. So it's just moved that entire graph up. Now let's look at the second example when there's something inside. And we have x minus 2 inside. So if you notice, that graph has made it move right 2 because I'm going underneath the radical, and the negative is going to make it move right. The positive would make it move left. And if you'll notice now, my x values, my domain values have changed. It's going to be all values that are greater than or equal to 2, but it has not changed my range. My y values are still going to be greater than 0. The curve is the same curve, but it's just moved then to the right 2. So you try the example of a translation in your notes. A real example. The Golden Gate Bridge is about 67 meters above the water. So the velocity is given by the function v equals radical 2gh. G is the constant 9.8 meters per second squared, and we need to graph this function. So we have v for velocity is equal to radical 2 times 9.8 times h. So we're going to first simplify by multiplying here. 9.8 times 2. So this is going to be, and then we also have a height of 67. So we can put that 67 here as our h2. So we multiply straight across all three there, and we get the velocity is equal to radical 13.2 approximately. And then you go ahead and just take the square root of that, and we get a velocity of 36.2 meters per second. So you're just plugging values into the function and then going from there. So you try the real world example in your notes. The last thing we're going to look at is in this function I have something multiplied by the radical x, and then I have something added outside. So I have more than one transformation given to it. So let's see what that looks like on Desmos. And what I'll do is I'll put that inside here. So here's our radical negative 2 radical x plus 1. So as you can see, it reflected it because it's multiplied by a negative. Because it's multiplied by a 2, it made it a wider curve. It's a dilated curve compared to my original. And since we added 1 on outside of the radical, it moved it up 1. So I have the maximum right here. You'll notice then my domain stays the same because it's all values greater than 0. But my range is going to be values that are less than or equal to 1 because it's all of these values graphed below that 1. So you try the last example in your notes.